Alrighty, so how do you use this whole Phet setup? Well, I'm clicking on that. And then it's going to give me a bunch of tools, give me a battery, some voltmeter, ammeters, and all kinds of things. So there's a battery right over there. Here's a light bulb I could hook up on it right over there. I can even I can rotate some stuff around. Or maybe I can unhook this stuff. I can click on that and clip that off and unhook it there. I can come back and hook it over to this side over there. I can take a wire and I can get a wire right over there, and it's hard for me to get to that one over there. I could put a switch, I guess. I could put a switch, and we put the switch there, and I'm going to rotate this around and click. There we go. So if I get this thing rolling, oh, there it is. I close my switch, and it is bright as I'll get out there. I can unclick, and there you go. So there's my switch. Now let's see if I want to close that, and I want to measure a voltage of my system. Move this whole thing over there. So if I want to measure what voltage, which is the electromotive force or a push, I could do it across the battery I could put this over there on this side. I could push this over there on this side of the battery, and hey, it's a 9-volt battery I've got over there. I could hook it over to this wire over here, and I'm going to find out that theoretically I don't have a voltage drop across there. I say voltage drop is because voltage is like a push. So I have the same push here as I have here. But when I connect this wire back over on this side of the battery, back over to this side of the battery over there, I'm getting a push out of that thing. And I'm getting a net 9-volt push. So the push here is on this side over here is 9 volts higher than it is here. Now you notice there's electrons moving over there. Normally the way we talk about concurrent moving, we talk about a positive current moving. So if electrons are going in one way, we have a positive charge moving the other direction. It doesn't matter which it is happening, but the positive charge flowing one way would be the same as the negative charge flowing the other way. Okay? So other things you could hook up. Let me unhook this right over there, because I'm going to snip that. Because I think I want to put an ammeter in there, because I want to measure the flow of current, or how much current is actually flowing there. Oh, there it is, 0.9 amps. Okay, so I could snip this over here, clip that, and I could also put in some more batteries if I wish, and then just see what happens when there I am, going back together. I could hit my switch and undo my switch, close my switch again. Now I've got a different amount of flow of current. So this is 0.45 coulombs per second, you'll learn. Or coulomb per second is the same thing as an amp flowing here. And once again, I could measure the voltage difference across this side. I could measure it compared to this side right over here. And that's a voltage difference of 4.5. That means it dropped by 4.5 volts right over there. Okay? So that's how you work the Phet. There's other resistors you could do, but what you're largely doing is this bulbs and batteries and some tools to measure the electromotive force, or the drop and push from one thing to another, or the actual flow, which is the ammeter. Oh, I could have clicked the conventional current over there. Look at that, guys. I could hit the conventional current, and there it is. Conventional current is a fancy way of saying the positive charge would be flowing this way, which is what Ben Franklin talked about, and that's what we're always talking about. So it shows the direction of flow for conventional versus the electrons. At the time, they didn't know electrons existed, but we do now.
Yeah, we do.
And we could add resistance to the wires, probably. This is a tiny resistance. So what would happen is, now you don't have to do this, because we're just doing beginnings of circuits here. Notice there's no voltage drop there. If I were to increase the resistance of my wire, we're actually losing a little bit of energy across that, because now the wires are not ideal wires. They actually have some resistance themselves. Okay? We could use that as a source in the schematic diagram. That's the how a battery would look. So now I've clicked everything to what a schematic diagram would look like in terms of what a battery is, wires, and so on. Click on the battery, and then I'm back to my normal picture-y stuff. But let's say if I have no battery, we don't do this for AP1, but you could also have a resistance in the battery, which would decrease the overall flow everywhere else. But that's an AP2 topic, not an AP1 one, so we're not going to worry about that one. So there's all kinds of things you could also choose to put inside of this. If you click down through there, you could put a dollar bill in there. You could put some coins in there, eraser, which is one of your exercises. You could put some different things into there to see if you could still light these bulbs. Okay. So if I were to take out this bulb, I'm going to delete that button. I can also change the resistance of these bulbs over here. Okay. So, and I change my resistance. You can see that changes the brightness over the overall bulbs there, doesn't it? Even though I'm only changing one, it's changing it actually everywhere, it looks like. Well, that's what you're going to learn about, is what's going on with that stuff. And so take a little bit and explore what's going on.